Let's start with circuit. So today I'm going to teach you about circuit in series and parallel. So as you reminded that you are a little confused with how we are deriving the equation R resistance in series as R1 plus R2 plus R3, and for parallel it's 1 upon R1, 1 upon R2 and 1 upon R3. So let's start out with this. So I'm starting with the series connection. So as we are having resistance in series, let's draw a simple circuit in series where I have taken three resistors here, R1, R2, R3. So as the current is passing in series, so here the same current will pass through all the resistors. That is same current I, whereas the voltage is V1, V2 and V3. Let's apply the simple Ohm's law for this. As we know, Ohm's law states V is proportional to I and V is equal to IR. We are going to apply that. As here voltage is splitting, so while our derivation we need to start out with the voltage in series, which is V1 plus V2 plus V3. As I have given you Ohm's law, V is IR, whereas voltage is current multiplied by resistance. So thus V1 we can replace with IR1. So here we are finding what is voltage at the first register, which is V1 is IR1, V2 is IR2 and V3 is IR3. Whereas Vs whole resistance is IRS. Now we can take I common. So it's R1 plus R2 plus R3. We can cancel out I from both the sides. Thus resistance in series is combination of R1 plus R2 plus R3. So thus simply we can remember, here we need to write out only the simple, like we have taken a simple circuit where I is the current which is flowing and potential difference between across each resistors be V1, V2 and V3. And simply we can find out the series. As we got the series as R1 plus R2 plus R3, thus equivalent resistance is sum of all the individual resistances. So we say that resistance in series is always greater than greatest. This is important to remember. Now let's start out with parallel. So here the current will split. So as the current is splitting here, let it be R1, R2, R3. Here the current is splitting, so we are going to start out a derivation with current. Now I in parallel is I1 plus I2 plus I3. As per Ohm's law, V is IR, so I is V upon R. We can replace I as, here voltage will be same throughout, so it's V R1, V R2, V R3. So V upon R1 plus V upon R2 plus V upon R3, whereas current in parallel will be V upon R parallel. Now V can be taken common, so it's 1 upon R1, 1 upon R2, 1 upon R3, V upon RP. Thus V can get cancelled. So finally we can conclude that resistance in parallel is combination of reciprocal of all the individual resistances. So here I have taken the three resistors. You can choose according to your requirement. So finally we can conclude resistance in parallel is lesser than the least value. Lesser than the least value means answer will be smaller than the smallest. Here in parallel, resistance in parallel is smaller than the smallest, whereas in resistance in series is greater than the greatest. So value will be highest in series and value will be least in parallel. Hope you all understood it and enjoyed the video.